Hi, Mick McQuaid here with part 5 of chapter 1 of R for Data Science, our textbook for this course. And in this short video, I'd like to talk a little bit about position adjustments. And there aren't too many position adjustments to talk about. This will be a brief one. So we're going to start out by providing a bar chart that has a colored outline around the bars. Wait a minute, what am I doing? There we go. So we have these bars, and we have a colored outline that's barely perceptible, maybe not even perceptible to you around them. Okay, now what we're going to do is get completely colored bars. Instead of saying color equals cut, we're going to say fill equals cut. So color refers to the line or the stroke, and fill is filling filling what has been outlined. And we can automatically create a stacked bar chart by assigning fill to some variable other than cut. Now we get a stacked bar chart, and we can also change fill to we can do the position adjustment of identity, and we will get a different result. We'll use identity, and we'll get some overlapping, and we'll use alpha transparency to partially compensate for that overlapping. And you'll see what I mean in a minute. So these bars are on top of each other. In other words, this bar is this size. And this, what appears to be this small bar here, is actually this size. These are overlapping, and they're partially transparent. The alpha has been changed to 1/5, so that's only 20% visibility of these things. If I changed alpha to 90%, let's change it to 4/5, so let's change it to 80% and see what happens. They're almost opaque at that range. And we can eliminate the fill altogether. Instead of having the fill, we can just have color is clarity, and fill NA, and position is identity. So now the position of these things, they wouldn't be visible, except that they're visible as lines, and you sort of have to use your imagination to fill them in. Another position that we can use instead of identity is, or fill, is dodge, and that's going to put them side by side. So that's pretty useful for some purposes. It should be obvious, by the way, clarity and cut are related to each other. So for the better cuts, we should see more of the better clarity. So the best clarity is IF, the worst clarity is I1. And you can see that IF increases as we go along. There are fewer of the IF diamonds that are fair cuts. And we see that for I1, there are more at this range than there are at any other range. Well, almost any other range. So we should be seeing more of the good diamonds. Basically, my point is here, of course, the diamond sellers are primarily interested in these diamonds, so we see more of these diamonds altogether than we see of these diamonds. Okay, we have an overplotting problem, and we can go back to our original, the very first scatter plot that we did, and redo that. I think I already mentioned this, but here it's mentioned in the textbook that we can see all 234 cars in the MPG data set by using jitter, whereas before we were only seeing a fraction of them. Okay, so we have position jitter, position dodge, position fill, and position identity. So all those are worth keeping in mind, position adjustments. Now we have the exercises. Let's see what the exercises have to say. Oh, did I do this one? I don't think I did this one. I don't actually. Let me just. That's not working. I'm just going to put it here. I think I skipped over it. Was it here? Yeah, I skipped over it. So this just makes it easy to compare the groups, so I can see the green group across here, or one of the green groups, I guess. I can see the brown group across very easily. This makes it easier to see that we have more of the lower grades at the lower clarities at the lower values of cut, and more of the higher values of clarity at the higher values of cut. Okay, back to the exercises. Let's see. What is the problem with this plot? How could you improve it? And of course, jittering is how we could improve it. So let's do that. So here is that plot. And here's the same plot but jittered. So we see a lot more values there. And we still see the overlying, the overall trend, which is the important thing, is that there is this linear relationship. Okay, question 2. What parameters to Jian jitter control the amount of jitter? So we'll have to look at the help for this, and it says it adds a small, well, I can tell you, we can read this, but I can just tell you width and height both add random amounts of jitter. We can use either one or both, and they'll both add. Width definitely allows vertical and horizontal jitter. Height also gives vertical and horizontal jitter. So you could use either one of those. Question 3, compare and contrast Genome jitter with Genome count. So how do we contrast these? Oh, here's how I thought to contrast these. So first, let's take a look at Genome count. Variant of Genome. Point that counts the number of observations and maps the count to each point area. Useful when you have discrete data and overplotting. Okay, so let's look at an example where we first use Genome count, then Genome jitter, and then both. Okay, so there's count. Now remember what I've said before when we've looked at plots like this. Imagine this is a stack of dots. Okay, now we're going to move the dots off of their positions. And we see that there are many, many more dots on the right, which corresponds with what we already know, that there are more diamonds of the ideal cut than of the others. Now when I put both of them on here, the original dot is back in the center, but it's pretty much obscured in this case. You can sort of almost see it here, but in this case the dots are so dense that it's basically obscured. Okay, and then last, what's the default position adjustment for Genome box plot? Create a visualization of the MPG dataset that demonstrates it. So let's do that. Jian box plot. The default position adjustment is dodge, so that's going to give us side-by-side boxes, and it's going to be demonstrated by this this series. And I think we've seen box plots before. Okay, so that's it for position adjustments. Next, we're going to talk about coordinate systems, and that'll be in the next video. So thank you for your attention, and that's that.